All right, we're going to go through some basic terminology here that you need to have as a reference for when we're talking about angles, angles in trigonometry here, as it were. Okay, so we're going to start by defining an angle. As in geometry, an angle is just a union of two rays with a common endpoint, whose measure is given in degrees. Okay, that's no big deal. Okay, now contrary to what your angle is defined as, we're going to talk about angles of rotation. So an angle of rotation is again similar to an angle that we have in geometry, but it's not static. It's allowed to move around. So as it were in this case, we say that we have one ray that doesn't move, and that's called the fixed side, and then we have the other ray that's allowed to sweep around either in a clockwise or counterclockwise direction, and that's called the terminal side. And of course, by convention, we're going to say that when we sweep in the positive direction, we are going counterclockwise. So here's a 45-degree positive angle as opposed to a 45-degree negative angle. Okay, so convention tells us that clockwise rotation is oriented as positive, and counterclockwise direction is positive angles of rotation, and clockwise angles are negative angles of rotation. Okay? Now, in that instance, then, we don't have to be limited by an angle of less than 90 degrees or an angle of less than 180 degrees or an angle less than 360. We have any size of angles that we want. Well, we're going to have what we call coterminal angles. We're going to consider what these, for instance, 45 degrees and negative 315. Okay, so 45 is our counterclockwise sweep of 45 degrees. Negative 315 degrees is our sweep in the negative direction. Okay, but what we visualize here is that the terminal side here is in the same position as it was over here. In fact, I'm even moving it. Okay, so when the terminal side of any two angles are lined up with each other, then we call them coterminal angles. So 315 and 45 are coterminal, but there's other coterminals to them as well. Okay, for instance, a angle of 405 degrees. So we sweep through 360 and then another 45, and we end up in the same position as we did with a 45. So that's another coterminal to 45. 675 negative, okay, which is 45 degrees short of a full revolution, okay, of 700, full 2 revolutions of 720 degrees, and ends up in the same place as 45. So these are all coterminal: 45, 315, 405, negative 675. So generally, there's for any angle, it has any angle that you're going to locate, you could have gotten there through any number of means, both with a clockwise and negative clockwise orientation of 1, 2, or 3, or 100 different revolutions. Okay, so what we're saying is we're going to call our angle of rotation angle alpha, and anything coterminal with that is going to be called beta. So basically, take any angle that you have, your 45, and add any integer multiple of 360. 45 plus a negative 360 gives you negative 315. 45 plus a positive 360 gives you 405. So that's how we're figuring coterminal angles. We're just adding or subtracting any multiple of 360. Any multiple of 360 accounts for one revolution of 360 degrees. Okay. When we're looking at the angle of rotation, we always want the smallest of the coterminals. Now, for convenience sake, we typically would place our angles of rotation within a coordinate system. Okay, within a coordinate system. Okay, typically we would do that. Okay, so if the angle is falling within the first quadrant, then it is between 0 and 90 degrees. If it's falling within the second quadrant, it's between 90 and 180. And you can see the rest of them as is down here. In fact, the very reason why the coordinate system is oriented with the quadrants 1, 2, 3, 4 in this counterclockwise orientation is very much because our angles of positive rotation are counterclockwise rotation. Okay, so what we want to do now in the next video is talk about, okay, finding out what the sine, cosine, and tangent values of these angles might be that are coterminal with some of our specific 30, 45, and 60 degree angles. Okay, and for that we'll move to the next video.